Hello and welcome to the Exploding Gradients podcast. And today we have with us Jerry Liu, the creator of LlamaIndex. LlamaIndex, for those of you who don't know, is a framework that helps you connect large language models with your own data. And this is something that has a ton of use cases, right? It could be from building your own customer service bot to answer your customers' queries regarding a product based on the documentation. It could be used to extract information from the huge amount of unstructured data that you have in your company, or it can be used to pass knowledge from knowledge sources such as books, blogs, podcasts, videos, and can help accelerate your learning. And this is just the tip of the iceberg. There are a ton more use cases that you can think of for yourself, and this has been shown in how fast this framework is growing. Over the last few months, this framework has been growing at a rate of almost 200% month over month, and it doesn't seem like it's stopping anytime soon. And these are all the reasons why I wanted to talk with Jerry, and I was super excited about it. And in this podcast, we talked about how this project got started, what are the core concepts behind the framework, his mental models to wrap your head around large language models, and how to augment your large language models with your own data, how what's the vision for the project and his long term and short term goal that the team is excited about, and how you can help contribute and join the movement. So without further ado, Jerry Liu for you guys. Hello Jerry, welcome to the podcast. Man, it is totally great having you, because like LlamaIndex over the last few months have really blown up, right? And it's super exciting to have the creator with us today. So how do you feel? How do you feel about the whole field? How do you keep up with it actually?
First, thanks, Ethan, for having me. I'm super excited to be here. Yeah, no, I mean, I think there's obviously just a ton of AI activity going on across a variety of different verticals. And so there's a ton of new research papers coming out every day. And if you look at Hacker News, for instance, there's always some new paper or publication being featured. And then if you go on Twitter, LinkedIn, there's always these new releases, cool demos, cool features being added by all the builders in the space. And so it's been super exciting to see. I think I don't really know if there's a magic answer to it. I have been just pretty busy, but it's also been a very exciting type of energy, if you will, because there's just a ton of stuff going on all the time.
Yeah, that's true. Do you have any like tips for like catching up? Because the rate of innovation has been so massive that catching up itself has been very challenging. So what do you do?
Yeah, I think I probably spend a undue amount of time on Twitter and just like again Hacker News and just like probably bouncing around between those two sources. There are a few kind of articles and market maps coming out that you find on these that you can just like browse and see what the current state of AI is. But that's basically what I track the most.
Okay, got it. But coming back to Llama Index, like man, I'm really curious of about how the initial stages of Llama Index came in. I know you shared it a bit like in another podcast too. But what was like the founding story? Like, what was the initial problem that you're trying to solve? How did it actually turn out into this big project that it is right now?
Yeah, totally. LlamaIndex started off as just a fun tool a few months ago, back in November, and at the time, I was primarily focused on just thinking about how do you solve the context limit problem for language models, because everybody was playing around with GPT-3. People were just starting to think about building applications, and then everybody was thinking about how do I actually have it understand and process data that's longer than 4,000 tokens. And so at the time, that got me thinking about just some novel structures to get started on building, to basically just like these structures can hopefully index a larger corpus of data and still feed in the relevant sections to the language model. So it's almost like I was at the time, it was very much a thought exercise, and so I was thinking about an analogy similar to a computer architecture, if you will. You have the language model as like a CPU, and then you have like the RAM and storage that's like the kind of like external storage system. And so basically, I was thinking about, okay, how does it make sense to build this like external storage system for the language model? So at the time, it was very much just like a thought exercise. I came out with this idea of like a tree index that the language model could use to traverse large corpuses of information. But As time went on and more people became interested in this project, it became pretty clear that there was an actual practical opportunity here because people were using similar tools to try to build applications on their own. And so that's what got me to pretty much like pivot the project into something that actually created real practical value for users. And so since the inception, LlamaIndex has grown quite a bit, and it's actually grown a lot in terms of tooling as well. So we offer, a variety of tools around data ingestion, data indexing, data querying, and we also offer a lot of supporting modules around there as well. For instance, evaluation, output parsing, being able to optimize token usage, being able to process nodes even further, and all this good stuff.
Awesome, awesome, man. One thing that I found very interesting is that when I'm looking at the space, there are two big projects that are there. One is Llama Index and one is LangChain. Both you and Harris have one thing in, like, a lot of things in common, but also one major thing in common, which is robust intelligence. Both of you guys have been working in the company, and then both of you guys built like super impactful projects. So what was that like? How did how like is that a coincidence or was there something behind it?
I think it was probably kind of a coincidence. I think both of us just happened to be interested in the space. I did have a few dinner side conversations with Harrison back in October about language models, and those were kind of fun, like idea bouncing sessions. But yeah, it's kind of funny how this turned out. Now there's two big open source projects. There's LlamaIndex, there's LangChain, obviously, and yeah, Harrison used to be my coworker, so definitely a relationship there.
Yeah, nice, nice, nice. But coming back to like Llama Index, like, and the initial stories, like, so you actually build out the first tree, like the first structure that you tried was the tree index. But how was the hat like? And over time, you added a lot of other indexes also. But coming back to the present, what has been like the most effective go-to indexes or like the basic pipeline that people actually set up?
Yeah, so I think there's a definitely a difference between how the project started, which was very much a design exercise, versus now, where we're very much trying to offer like practical value to users. And so how it started was very much the tree index, and I can kind of paint a picture of why we came up with the idea. And from the perspective of like a thought exercise, it's kind of cool because basically the idea of a tree index is that you're not going to use any other machine learning model or technology. Like you're not going to use embeddings, you're not going to use whatever. You're going to use the language model itself to both process information, organize information, and traverse information. So just from like a thought exercise perspective, that was kind of cool to think about, like how you actually kind of create that structure. And one of the most intuitive structures that came up with was this idea of a tree. Um, there were, of course, practical limitations. And the tree index still exists today, but I pretty much like just encourage people to not use it, except if you want to use it as like a router. The one is just it's very slow. Pretty much like, then we can talk about this like language model calls, especially if you're stuffing the input window with a bunch of tokens. It just takes a few seconds, and so especially if you're chaining repeated calls together, it just takes forever. The other part is that errors propagate over time as you chain LLM calls. And so if you're traversing this tree, and let's say, like GPT-3 had like a 90% success rate, etc., and it picked the wrong answer upstream, then everything downstream would break too. And so just from a kind of mathematical perspective, just statistically, the errors would increase the deeper and bigger the tree was. So there were just a few practical concerns about making that useful. However, it was fun, and I think it got people excited. And so then, as we built out more indexes, I would say probably the most common paradigm that most people start out with is just using some sort of vectorization or embedding based approach. And so you take in a bunch of text, embed it, store it in some vector store. That's probably like the most basic thing you can do. And then you just like have a system set up where you can basically do retrieval using embedding lookup and search. Nowadays, there's like other techniques, like you could have metadata filters, you could have hybrid search, etc. But basically, you call some vector store service to get back a set of documents, and then from there, you can like take the retrieved documents and put it into input prompt and synthesize a response.
Yeah, I mean, I have been super like it has been super surprising how effective that simple embeddings like struct index has been because okay, if you have the data and if you polish it very quick, like if you like do some basic filtering and cleaning on the data, the results that you get are like super good. That itself is enough for like an 80% 90% solution that you can actually produce, like productionize.
I think so. I think the one thing I would say about that is it is very easy to use, but I think for a lot of people, I think most people would start off with an embedding based approach when they first start creating a project. But I would probably caution against overfitting to that approach. And the reason I say that is because it works well if you kind of understand the technique and the type of question that you're going to ask, which requires like a fact based retrieval lookup approach. Like if the question you ask can actually be found in a specific section of the document, or like you trust that embedding similarity can do its job. There are a lot of cases where embedding similarity doesn't do its job, and you're going to need some kind of more structured primitives to query over your data. And that's actually something I can talk about because that's part of something that, ideally LlamaIndex provides as a generalization of this overall framework of retrieval and synthesis. And out of those, like this idea of top K semantic search is just one instantiation.
Yeah, I would actually like. I had the follow up question. Like, could you give some few examples over that and go deep on that topic? Like the other solutions that people, the other things that people can actually build on, like try and use the other techniques.
100%. So we have a big section for different types of use cases that you can use with LlamaIndex. But let me just take a step back and just paint a picture. Think about LlamaIndex as a tool set that hopefully allows you to create this black box, right? And how this black box works is it takes in some input, which is a query, and it gives you back the output, which is the response that you want, plus a set of retrieve sources. And so under the hood, we manage the interactions between your language model and your data, depending on the use case, depending on the input, to give you back the results that you would want. And so it's a very general framework, right? And so I think like one of these instantiations is through like top K semantic search and being able to get back the results. But there's other approaches that we can do too. And that really is the end goal because we think there's just a ton of complexity in this area of like retrieval and synthesis, on top of your data using language models. And we want to provide users the tools to solve that. So let's just walk through like a few basic examples. One is let's say you want to do summarization over your documents, right? And so just like first, just naive like top K embedding lookup is not going to just give you the right documents to do summarization over any source. You're going to need some sort of other filter or index basically to retrieve the relevant documents. The next part is, let's say you want to ask a question and you don't want to basically know beforehand whether or not that question is going to be a summarization question or like a lookup question. And so one thing we provide you is actually some tools to provide like a unified query interface. You ask a question at the top level. We show tutorials on how you can actually define like a router to basically route this question to a list index, which performs summarization, or like a vector index, which performs top K embedding lookup. So that's something you can do with LlamaIndex, and that's something you can do pretty easily without too much setup work. So I could keep going. There's actually a bunch of stuff, but just like to like put it a bit more concisely, we also provide support with structured data, and so we also provide support with defining graphs for different types of retrieval use cases. And so, for instance, depending for a structure index, you could do text to SQL. If you choose to define graphs or relationships between nodes, you can actually do more complicated retrieval and synthesis modes, like for instance, being able to compare different documents together, being able to kind of like, synthesize stuff across different documents, and being able to ask kind of like repeated questions over different document sources. Break down a complex question into simpler questions over like different document sources. So we provide a lot of these modules within LlamaIndex. And the way I would think about it is each tool set or building block, for instance, like an index module or like a query module or any other module that we provide, each module provides like a certain way of kind of getting certain results out of your data. And so that by itself is very interesting. And then the question is, how do you actually build some sort of like unified query interface over this data? So because you have each module which solves like a slightly different use case, like you'll call the structured index for a SQL database, you'll call do a list index for summarization, maybe a keyword lookup table. And so then, one of the questions is, how do we abstract away some of this complexity? Like, you want to ask a question. How do we figure out what's like the right index to route to, and then answer the question for you? And so we provide some of these initial tutorials on how to do that. But that very much is both kind of like within some of the short-term like functionality of LlamaIndex, but also part of our long-term vision is, given just this set of documents and given just like a variety of questions that you might want to ask over these documents, what is the right state to build over these documents that allows you to perform different modes of retrieval and synthesis? And then how can you basically kind of provide this unified query interface so that you can ask a question and then it can route to the relevant documents through the state that we define.
Got it, got it. So, okay, got it, got it. So that is okay. That is the end goal that you guys are building towards. But you also mentioned the query router, right? Does that is that like the router that actually map like routes the different types of queries that one could possibly ask LlamaIndex or your documentation? Is that part of the like the solution that you have currently?
Yeah, so you can actually do that in a way within LlamaIndex right now. And we're kind of thinking about ways to make it more general. One way to think about it is that a router is basically like kind of a node that has like links to a bunch of other indexes. And so if you view it from that perspective, you can basically use our composability framework where you can compose this like router index basically using the tree index actually, because the tree index basically just picks one of the children. And then you can use that, and then it will be able to take a question and route it to the underlying index, and then the underlying index can solve that problem. One way to think about it is basically like a mini agent that's kind of like, but specifically for being able to choose which index is the right task for the job.
Got it, got it, got it. Man, like all that itself is all the technical stuff itself is an interesting thing. But I would be highly recommend people to check out the documentation because the docs also have a lot of like specific tutorials where like, specific use cases where you can actually try all of these stuff out. So do check the docs for that. But like switching back to again the overall picture, like what have like there has been a lot of interesting use cases and a lot of interesting things that people have built, right? And part of it is because you can easily get started with LlamaIndex because of in a couple lines of code. So what has been some of the interesting use cases that you have seen from the community that people have built?
Yeah, definitely. I think, in the beginning, and even to this day, like a lot of LlamaIndex is really just being able to get you up and running really quickly over your own private data sources. And so a lot of the interesting use cases is over the diversity of data sources. So for instance, like, from standard stuff like PDFs to like web pages to even other stuff like videos and audio. Like we were one of the first projects to basically create like some sort of video to text parser from one of our contributors. And then basically you can now like, transcribe video to text and then ask questions over this text. And so even for that simple use case, it's quite interesting because if you think about it, it like simplifies the data landscape by quite a bit because all of a sudden through a three-step process, you could transform just raw unstructured data into text, index text as like a central data format, and then ask questions over it. You don't actually need to do a ton of like complicated parsing, like processing, right? Like ETL, like being able to write a bunch of like this custom logic. You can just trust that you can store text in an unstructured format and then ask questions over it using a language model. So I find that part pretty fascinating, actually. Um, I think nowadays there's a lot of like excitement about agents and especially stuff around like baby AGI, auto GPT, like all the stuff that can do repeated stuff for you. I would say some of that stuff is more just it's kind of like an interesting demo as opposed to offering like practical value. But at the same time, there's a lot of we also realize there's a lot of like very similar concepts that you can build pretty easily with just LlamaIndex as like some of the core primitives that we offer with like indexes and vector stores. And so, for instance, like if you think about what are the components of like an AGI system, there's like task management. There is being able to like index into like the memory of like previous actions. There's being able to plan new stuff. And so a lot of these modules you can actually represent with simple like LlamaIndex data structures and then be able to create some AGI, baby AGI type model yourself. And so I think some of our contributors have basically built these like cool AGI demos they could actually find both in the repo as well as Streamlit. And then we also have some other contributors building this too. Like one of ours contributors built this like medical agent research bot, which I thought was super interesting, using LlamaIndex itself.
Yeah, that was super good. And the baby age, like all the age stuff also has been like pretty interesting, but they are at a phase where it's like more of an interesting demo, but use, use cases are pretty hard. But right now, all the basic components are there, like to build, like, okay, even if you think of it as a human brain, it has memory, it has the ability to plan stuff. So yeah, who knows, maybe something interesting will be there. But but one like con of this is, right, like, okay, so say if I'm a builder, I'm building a product that like solve some problem with like with other LlamaIndex and other frameworks, because LlamaIndex does its job like too well, because I don't have to worry about loading, I don't have to worry about how effective the thing is. Like for someone building a product, that creates like it brings the question of where I can build my moat, because okay, the technology side is fairly easy to set up with all these pipelines, but then so my I have to figure out where exactly my moat is. It has to be something other than tech. How do you think about that problem?
Yeah, it's a good point. I mean, I think I think there still is something to be said about the technical side. But to be fair, I think we want to offer a lot of the core tech that powers the QA systems for users, basically, so that they don't have to worry about it. I would say, again, going back to like basic semantic search, like it works well to get set up and running. There's a bunch of stuff that we want to add to make sure that you can solve a broader class of queries than just pure kind of like fact-based lookup questions. But we can take responsibility for that. And then in the meantime, I do think that the application layer should not be just branded as like a thin wrapper around AI, because I just think all of those applications are not going to have like differentiable modes. And the reason is because like if you just look at any use case emerging on like a novel application with AI, for instance, like even the text to SQL stuff like a few months ago, or even with kind of being able to build a chatbot over your PDFs, the underlying tech for that is honestly pretty simple and can be open sourced, right, by our project or by LangChain or other projects too. And so I do think it's like the application developer can like depend on the tech. Like the tech will probably be open source. It'll be like widely discussed within the community, but they need to build like differentiated product high level UXs that really encourage like kind of like different user interactions and modes of behavior, with the AI enabled application. And so I think it's less about like engineering some fancy algorithm, right? If you're an application builder, and more about thinking just fundamentally, right? Like what are the best UXs for interacting with AI systems these days? And if you look at like the spectrum of like AI enabled applications, there are certain use cases that people really do enjoy using. And then there's certain use cases that do feel a little bit more like an add-on feature. So for instance, I was thinking about this the other day. One thing that I really do enjoy using, right, just because it's like a really nice UX, is like Copilot. Like just the fact that you don't even have to press a button, you just like write a line code, wait like half a second, and you just press tab to complete it. It's just very nice. Versus like I think if you tried to build, for instance, like some sort of agent-based system where, but like you like maybe didn't set up the product UX in a way that's like nice or pleasing, then there are a lot of downsides of building to trying to depend on LLMs too. Like for instance, they're very expensive and also very slow. And so if you like pass that on to the end user, they might get frustrated with the experience too.
Got it. Yeah, that is true. Basically, yeah, the build, as builders, we have to think of like what other UX is one, definitely one mode. Like I also like Notion's UX because the whole it's not, it is basically text, but the whole where you can select all the text, interact, ask more questions, and like it is much more intuitive than like chat GPT interface itself. But yeah, the UX, the data, all the other sides becomes even bigger mode than the technical side. Yeah, that is true. But coming to the project itself and the future of the project, like what do you have in store? Like what are the like the most in the like in the on a like a short term thing, what is like the most interesting things that you're working on? You told that there is a zero point 0.6 release coming in, so I guess you are pretty excited for that. But even after that, what are like some of the couple of projects that you are pretty excited about?
Yeah, so I'm glad you asked that question. So I think 0.6.0 should have landed by the time that you're hearing this podcast, and I think it's actually related to the previous question, which is about how do you offer the best ergonomics and UX for the end application developer using our tools. And so I think one thing that I would say LlamaIndex does very well these days is the fact that it offers like this high level API, gets you started, 3 lines of code, right? Plug in your favorite data loader, index it. Now you can ask a question over it and then get back an answer. And so you can do that super easily. I think one thing that we have been, the reason this like refactor is happening is because we want to solve both the simple use cases as well as the more advanced and customizable use cases. And the more advanced you go, typically, especially if you're a more advanced developer, you'd want a bit more modularity, customizability, flexibility, and being able to kind of like define your own like core models and various components of the code base in order to implement kind of like your own retrievers, synthesizers, all these different types of things. And so that is very much what the refactor is going for. That is step one, which is just from kind of like this very high level, very easy to use API to really exposing these like modular components that people can very easily extend and build on top of themselves so that they can define their own tech for retrieval and synthesis if they want. And this is something that a lot of users have asked for. The next part is the fact that we want to make our tool set a bit more principled and more enterprise ready. And a lot of that comes with thinking a lot about how do we best store state. Because you can almost think about LlamaIndex. One view of it is like some sort of stateful service management for your language model application, right? Because we are dealing with kind of managing state for your application. Language models are inherently stateless, at least right now they are. Like GPT-3, GPT-4, who knows about the future? But basically, you have some input, you got some output. And if you want to operate it on top of your data, the question is, how do you define the views on this data? How do you maintain the state so that you easily use it with a language model? And so we're really trying to create like good abstractions for that, both like conceptually, but also provide good integrations with, the databases like vector stores, object stores that you would typically use. And so there's just a lot of kind of like storage abstractions that we're trying to clean up and make this a lot more enterprise ready. I think going ahead in the future, there is just like some general components that we're super excited to talk about. So for instance, one idea is continuing to push on this idea of having this out of the box, like unified query interface for users. Imagine for a user, they can set up this service that they can deploy on top of their data. And we abstract away a lot of the complexity about, we should define these indexes over this data, or we should define like these configurations or this mode of interaction. We can configure a lot of that automatically. And then given a top level question hitting this API service, we can figure out, the right interactions, the right services to call in order to give you back the response that you would want. And so a lot of this is going to be very interesting because I really think this ties into this idea of this like broader agent style interactions with your data. But I think here it's interesting because I almost imagine this idea of like different kind of like mini like data agents over your data system. And being able to pick like each data agent is specialized at kind of like picking the right tool for its job. As a very simple instantiation right now, you can think about our router abstraction, right, as like a mini data agent that can route a query to the right subindex. So you can imagine that, and then you can imagine like sub data agents too that could like figure out the right parameters to insert to query a vector store with. And then all these different kind of services interacting with each other under the hood, and kind of again providing this clean high level interface to the end user. Hopefully some of that made sense, but the high level idea is that we're trying to create this like idea of just abstracting away a lot of the retrieval synthesis complexity and taking advantage of all the latest techniques that are happening these days to build that kind of unified query experience for users. And at the same time, from the community side, offering the building blocks for more advanced users to kind of customize and create different components themselves.
Got it. So in the short term, you guys are exposing all the small components that you can, as a user, that you want to modify, so that your index becomes more performant on your specific data set. But on the long term, you don't have to even care about all modifying that. It'll be just, you'll give your data to Llama Index, and that will take care of building the right indexes, the right set of agents that can abstract away all the complexities, that like all the complexities and configurations that you might need. And then just it's just one endpoint, you ask your questions, and that's it, you get the answers you want.
Exactly. And I think it's honestly very powerful because it's a very hard technical problem, but we do think it will provide a ton of value because just if you think about the average developer, like a person who's trying to understand all this data and figure out how do I like hook this all up with the language model and figure out what the best like interaction pattern is, there's just a ton of complexity there. And I think we want to make that as easy as possible.
Got it. Now, as like, okay, so you also mentioned that there are a lot of community like contributions also. But as someone who's interested in LlamaIndex and want to contribute, what are like some of like, there are a lot of different modules, and there there is a lot of different moving parts right now. Like, as a contributor, where would like the best place be? What are the different areas that I could help? And like, yeah, what are some of the areas that people could help?
That's a great question. So we have a contribution guide in the core repo that consists of a ton of different modules that are pretty independent and are relatively easy to contribute to. So just as a very basic example, we have data loaders. Those are just massively parallelizable. We have like over 80 data loaders right now, but we could always add more. There's just like hundreds of different services that we still want to integrate with. Um, there's other modules on that list. So, for instance, like retrieval modules, especially when 0.6.0 comes out, as kind of query engine modules, optimizers, being able to reduce token usage, post processors, text splitters, evaluation modules, like output parsers. And so all of that stuff is described in the doc, and all of those are pretty independent, and those things are pretty easily extensible. In general, there's like the kind of like core features that we love to contributions from, and then there's also just like general kind of like bug fixes, like documentation updates. We all always welcome like cool experiments too. We have this new repo called Llama Lab, which is just a cool showcase for different types of like agent-based experiments or any other experiments. And so if you're interested in contributing any of those projects, would highly encourage you to. The other thing is we're doing like a t-shirt giveaway. I think we've like mentioned this, is that if you do contribute like a core module, you'll get a fresh limited edition LlamaIndex t-shirt. And so that could be a nice little gift to have.
Nice. Motivation. But yeah, that will be pretty that that is pretty good. But yeah, there are different lot of components that are there overall, because LlamaIndex by itself, it's a very new project. So there will be a lot of components that are moving, lot of opportunity for people to dive in. And yeah, and the growth has been pretty crazy for an open source project. So yeah, a lot of opportunities for contributions from outside. But as a project, right? Like, because as more and more people are coming in, more and more people are using it in enterprise solutions, we want more like, because right now it started off as a hobby project, but more people are becoming like dependent on it as an enterprise. So do you what are some of like the enterprise use cases? So do you have it in mind, like some things related to that?
Yeah, it's a good question. I think a lot of the enterprise use cases arise from things that are complementary to the open source project. And so, for instance, we're basically dealing with data ingestion, management, and querying, right? And so, as data volumes scale up, especially if you're dealing with like gigabytes or terabytes of data, then you might want to rely on like a hosted service that can manage a lot of this for you instead of you just being able to run this locally on your laptop. And so that's very much something that we're thinking about. The next part of this is because we're dealing with data, there's a certain like table stakes enterprise features that pretty much like every kind of like hosted offering needs to have, which is like data access control, like SOC 2, user management, a lot of this type of stuff. And I think that's something that wouldn't make sense in the open source project anyways, just because that's something that you should be able to easily download and install. I think there are a few additional things that we're thinking about. For instance, like just being able to really optimize between different model use cases. Like if we're able to profile like the performance of a model given your cost budget, being able to provide you a service that can, really understand and profile your model performance and allow you to pick the best like embedding model, language model, and other types of services over your data and use case. And some of that might make sense in the enterprise version as well.
Like just out of curiosity, have you had like experiences where like okay, right now people start off with a very general LLM or a very general embedding, but has there been use cases where fine tuning your LLM or fine tuning your embedding has given like even though it's smaller, so it's cheaper to run, but has given like or at par performance or better?
I think that's actually very much an open question right now. So if that's something you're interested in contributing, I would love to see more experiments on that end. I think people are still actually trying to figure that out. I personally would be very interested in a distilled model that's very good at retrieval and not necessarily good at knowledge. And so something that's way faster, cheaper, but is still very, very good at reasoning and retrieval. Um, so would love experiments on that end. I think in terms of embedding models, I think like by default we use OpenAI. I think OpenAI like language models are still just probably the best. Like GPT-4 is just very very good. I think embedding model wise, I've seen a lot of people start to use like Hugging Face and just like like other types of embeddings because if you're just trying to do some like cheap semantic embedding, you don't necessarily need like the full power of like this giant model anyways. And so that's something to that is very interesting to explore is to what extent can you like trade off a little bit of performance for just like free cost, right? And something an embedding model that's locally hosted.
Got it, got it, got it. All right. I guess we have to wind up since it's almost time. But we covered a lot of interesting topics, and all the docs and the links that we discussed will be given in the description. So you guys do check it out if you want to know more. And also the Llama Index Discord community is always there, so you can carry out this conversation. And if you have any more doubts, you can directly pop in there and ask. So with that, thank you so much, Jerry. It was really fun talking to you. We got a lot of insights and ideas about where the project is going to go and what the main components are. And yeah, so pretty excited to see what happens in the future. And yeah, fingers crossed.
Thanks, Ethan. Really great being here, and thanks for the chat.